to talk about the natural log function, I think it's probably good we start again with our natural exponential function. Remember, with the natural exponential function, our base is about 2.7. So we're going to have this magical point. Remember, that was 0, 1. And our second point here will be, we're going to go 1e, which is about 2.7. And we have, of course, y equals 0 was our horizontal asymptote. Now, if I find that inverse function, which will be the natural log function, of course, I'm going to have a shape that looks something like this. And here is my natural log function. It's going to go to the point 1, 0. I'm just taking this and exchanging x and y. And 1, 2.7, oops, I mean e. Don't forget that e just represents a number very close to 2.7. We're going to be E1. And y equals 0 becomes x equals 0. You can see if I reflect this over this y equals x diagonal line, I get the inverse. So this is, we'll call this y equals log base e of x. Now, you'll get laughed out of the building next year if you write it like that. We don't write it log base e of x. The quick way to write this natural log is to say ln x. Note, ln x is the same log base e of x. They're the same. Instead of writing it like this way with the base e, we write it ln. It means natural log. For x is greater than 0. Now, I've said this many, many times. If x is the argument of the log, it has to be greater than 0. We have restrictions. Y equals natural log x is true if and only if, that's what this IFF means, if x is equal to e to the y. In other words, these are equivalent statements. We can write this expression as the log statement or the exponential. They are equivalent. They're equal. Note, f of x equals log base e of x is the same as natural log x. We think this, but we write this. You have to understand that this means that the base in this particular problem is e, which is just about 2.7. We can evaluate natural log problems. So natural log of 2, remember, this is the equivalent of saying log base e of 2. So we're playing this game again. The answer to a log problem is the exponent e, 2.71828. To what power gives us 2? When I put this in my calculator, I'm going to get, give me 1 second, 0.693142. So this is when I have to go to my calculator with. E to this power gives us 2. Not a problem because the argument that I'm using is positive. Now, again, I'm doing here, in this particular problem, I'm saying log base e of argument 0.3. And again, I'm asking e to what power gives us 0.3. When I put the 0.3 in, my calculator spits out negative 1.2039728. Notice the exponent, the answer to log problem, the exponent is the exponent. The exponent can be negative. We can have a negative exponent. E to this power gives us a positive argument. Here's the problem, log base e of negative 1. We're asking 2.71828, approximately e, to what power gives us a negative value? And there is no answer. That's why my calculator will give me an error message. Why are we getting that error message? Well, let's graph y equals natural log x. We know it's going to look like this, and it's going to go through this point 1, 0, and then E1, or 2.71828, 1, and it has this x equals 0. So that's x. Look what we're doing with x. So if you try to do y equals natural log of, it was in our last problem, -1. You're saying, what's the y value when x is over here at -1? But look at our domain. Our domain is 0 to infinity. I'm very careful to write two curvy brackets there. So that's why there is no y value when x is -1. There is no y value. That's why you're getting an error message.